So in the previous video we talked about zeroth order whole. Right, so the zeroth order whole and its whole system is over here. Alright, and you're gonna input into your plant. Into your plant with some G of S, which is also some continuous system or analog system, interacts with the sensor, things like that, come out as a time domain still. It's still analog over here, up to here. And then after that you do some shit, and then after that coming over here. And you're gonna convert your analog to digital now, because you want to compare it with a digital signal from your input, or your reference signal. So you're gonna compare, and therefore before you compare you need to convert your analog to digital, and that is a very important thing over here right now. Alright, so you somewhat get the feel is that this zeroth order whole is somewhat in the continuous domain already, or analog system. So analog system, you interact with the plant's analog system G of S and things like that. It's all analog over here, this chunk over here. And then soon analog to digital, you need to do something. And this is why we're gonna combine all this thing all together in this video. Alright? To a shorter form, to let you understand better, is this. You input your zeroth order whole, alright, into the, actually this part over here should be zeroth order whole lah. I should have put it over here. But anyway, you're converting your digital to analog. Alright, so this analog over here is somewhat your zeroth order whole, and then you're going to input into your transfer function, alright, your plant, your reliability plant. Alright, then your plant and the sensor, whatever thing, will output some analog system also, maybe the position of the fan or the position of the motor or whatever thing you want it to be happy. Anyway, and then you're gonna convert your analog back to digital already, because you want to compare with your reference signal. Alright, and then you're gonna output, alright, as somewhat of an error, because over here is your error. Yeah. But this is not exactly all the case as an error, but just some output in terms of the digital one. So you convert digital to analog, and then analog to digital back. So we are doing this thing. As you can see, we somewhat do with terms of the zeroth order whole multiplied by the G of S. Alright, then you're gonna Laplace transform this thing first. Alright, because you want to do in terms of time domain. Alright, time domain analog, and then you go to digital. And so once you Laplace domain, it becomes a time domain. You're gonna Z transform this thing, become a digital system. Dun dun. Yeah, kind of not cool, right? Yes, this is something that's also in your book. Alright, it states that you're gonna inverse Laplace whatever thing that you have. Although this is something real weird. I don't know what is it meaning, but this is something to the extent is this meaning, for what I understand. Alright, that's why I don't depend on this thing, because I don't even understand this thing. Alright, I suck, never mind. Let's go. So therefore, let's do something that is familiar with us. Alright, we know that zeroth order whole is this one. In the previous video, we know that the equation of the zeroth order whole is this one. Alright, and then now, since we know that this is zeroth order whole, which is this one, you're gonna multiply with your transfer function G of S. Correct? And therefore we're gonna, once you do that, you're just multiplying your G of S over here. Okay? So I have minus, is it? No. G of S, E minus ST, S. Okay? Yeah, I'm gonna multiply in the G of S. So far so good. And for the Z transform, so-called the commutative system, is that you will have Z transform A plus B. Alright, you can have a ZA plus ZB. Okay, so I'm gonna individually Z transform each of them. Alright, but however, Z transform doesn't mean that you can do this. Alright, it's not equals to ZA and then ZB. Alright, this is totally wrong. You cannot do that. You can only add up the Z transforms, but you cannot multiply the Z transform together. Alright, so not multiply, but rather than, you get what I mean. Okay, so just take note. Okay, just take note. Okay, and then yeah, actually you don't get what I mean, right? But simply say that you don't Z transform AB, you don't simply ZA first and then ZB. You don't do that. Alright, that's all that I want to convey. Okay, but you can take ZA multiply or convolution with ZB. Alright, individually first. Alright, but that's why I say never mind. We don't continue to talk about that. Anyway, let's continue to this one. Since we know that we can Z transform this one individually, so I'll just Z transform them. So what we have is simply Z. I'll just rewrite. Okay, so far so good. Therefore, this means that this thing over here is the one that they're talking about. The first part is this one. This one is the first part. None, and then the second is this one. As you can see, is this one. Alright. Now, how do we transform this thing? Alright. Take note, E minus ST. Next time when you see this, straight you know is Biang, Z minus 1. Okay? Provided that there is some K over here. Alright, where K is equals to 1. Alright, please remember this thing. Alright, if K is equals to 2, for example, if it's E minus S2T, then bam, this is Z minus 2. If it's S3T, then Z minus 3, etc. So because if you still remember just now from the previous part, we say that E minus ST is a delay, right? Coming from the T minus capital T, right? So you have some T point over here, and then you dealing with T minus T over here. This is a T with a certain delay of capital T, so it's over here, right here. So there is a delay. So this delay later on we say that it's E minus ST, right? If you just go back to the previous video and watch, you should get what I mean. It's just some first shift theorem stuff. So first shift theorem means that you're going to shift by one delay, or not in terms of that, but rather than talking about shifting in terms of delay. So you have delay by 1, so therefore this Z minus 1 is telling you that we are also delaying by 1, because we know that previously already. So I've talked so long, you may feel a bit bored, but anyway, so this thing will become Z minus 1, and output over here like this. Okay, so the G of S over S, we still don't do anything about it. Just that Z minus 1 you somewhat because it's just indicating that you are delayed by 1, that's all. So you can somewhat switch the delay by 1 into the Z domain, that's all. But we need to solve for this, because it's still in terms of the S domain. Alright, so that's why this is something for you to think about it. Alright, because it's kind of like straightforward, because this thing straightforward come out is this. Just to let you know is that the E minus ST is this one, that's all. Alright, although we know that the commutative system doesn't allow you, because ZAB we say that we cannot ZA and ZB like that, we cannot do this, but what they are doing now is this. That's why, but never mind. Alright, just take note that only for this case you can do that, alright, because of the just indicating that this system is delayed by 1 time. Alright, if it's minus 2, is this system delayed by 2 times, that's all. But anyway, let's continue. But to keep this in mind, this is a very important concept, please take note. So now we have my first part doesn't touch anything, and my second part being derived. Let me rewrite them in a more nicer manner. So I'm simply rewriting this one as this one, that you can double check, and then this one as this one over here. You can double check. Alright, so I'm simply transforming this whole thing over here into this thing over here. Okay, just check it out, just take a look a little while, it will digest. Alright, and now I'm gonna factorize out my Z stuff. This thing is the same as this thing, can factorize it out. So if I were to factorize it out, I'll have Z GS over S. Alright, so if you factorize this thing whole thing out, you'll just become 1. Alright, so I have 1 minus Z minus 1 like this. Okay, now this is the form like this, same thing. Okay, maybe I should bring this over here, at least it makes you feel nice. Alright, so you have somewhat reached a certain point. Alright, so far so good. This whole thing is something like you are Z transforming your transfer function already. Alright, but please take note that we haven't finished yet. We don't know your transfer function. you have to do something about it. You haven't finished transforming, fully transformed yet. You haven't ripe yet. Your Metapod still Metapod. Alright, you need to transform to Butterfree. So how do we do this? We have a transfer function with this over here. A over A s plus A. Okay? That's why hold on a while. Trying to make things neater for you to see. Okay? So now it's A over S plus A, which is your GS. So you know your GS is A over S plus A, and then you also multiply by 1 over S over here, right? So it's like this. So this thing over here is simply this one, alright? I'm taking only Z transform of this one now. Okay? I will just bring this. If you don't believe me, it's this one. Okay? It's this thing. And the more I do, the more I feel that you can somewhat like a ZAB, and then is equals to ZA ZB. I don't know. This my teacher tell me is not equal. I don't know. See how. Okay. Let's continue first. Alright. So therefore, we know that this belongs to the G of S over S, the Z transform part. Alright. But you're going to transform it. So now what we can do is to rearrange this thing into a time domain first. Right? We're going to inverse Laplace this thing. So if you do that, you have this thing over here. You are using the partial fraction. Alright, it's straightforward lah. Never mind, let's do together. Alright, I use the cover up rule in case. Alright, because in the future you may forget. So when using cover up rule, right, when I set my cover up rule as my root as A in this minus A in this case. Is it minus A? Sorry. If I were to take my roots over here as 0, so I'm simply ignoring this thing. Okay? And therefore this is 0. So A over A is equals to 1. Alright, so we know that A is equals to 1. Alright, therefore just simply rewrite here as A is equals to 1. Ta-da! Alright, now we're going to cover up, instead of this one, we cover up this one. So we're going to take the roots of this one. Just now we take the roots of this one, right now we take the roots of this one, this whole thing. So it's minus A. Alright, so I'm gonna cover up this one. So A over minus A is equals to minus 1. So my B is equals to minus 1. Bam! For when I sub in my A and B, I'll have this one over here. Alright, so it's just 1 over S. So A is 1 minus, because it's minus 1, so minus B is 1, so it's like this. Da-da! Okay, so far so good. Alright, so now you're gonna change it to the time domain. I think you're professional already. 1 over S, you change your time domain is 1. If you change 1 over S plus A, what you change it is minus ZAT. Alright, that's straightforward. Okay? And then now you're gonna use your table. Alright, your table. Where is the table now? Let's just take some of the values. Let me take a look. Hold on a while. Aha. So you can see your 1 over S, alright, when change it will become 1t, alright, then t will become k, and then you can Z transform. So the Z transform of 1t is simply this one, alright, and our Z transform of 1s is this one. Okay, how do we do this? Is that 1t is, since we know that it's 1 over 1 minus Z minus 1, alright, because I just want to prove to you that is in the end it will become Z minus Z, is that 1 minus 1 over Z, because Z minus 1 is inverse 1 is just 1 over Z. You multiply everything by Z over Z, because it's just simply rearranging, as taking as 1. Right, this whole thing is still 1, so you're just rearranging your stuff. So you have a Z over Z, Z minus 1. Ta-da! It's this one over here. Same thing. Alright, if it's a E minus AT, alright, simply this one. Okay, so you have 1 minus EAT Z minus 1. Same thing, you multiply by Z minus 1. Maybe I should change this Z minus 1 to 1 over Z. Okay, so you multiply everything by Z over Z. So this thing becomes Z, and this Z will multiply with this Z. 1, I mean it will become z, and then this z will multiply over here. So this z will multiply with this z over here, then they will cancel each other, become 1. Therefore you have minus e minus at, right? So which is shown over here. So what can we conclude from this transformation is that whenever you have something like, where is it, like 2 or 3, when you z transform, alright, it will become z minus 2, or z over z minus 3 for this case. So wherever you do that, you are doing that form of manner. So the z minus r, or some constants, is the one that you need to really check it out. Alright, so be very mindful of that. And you may wonder one thing. Just now I say that when you do e minus at is equals to z minus 1, then well, now why are you doing the z transform suddenly become like that? Alright, because that's not what I'm doing is not z minus at. What I'm doing is z minus st. Okay, don't macam. So the a is not, if it's a, then you're gonna use your z transform table. Alright, or the one that I told you, the z over z minus your whatever thing about a. Alright, so take note that when it's talking about e minus st, then it's equals to z minus 1, negative 1. So this one is totally wrong. Don't do this. Please don't do this. A lot of careless mistake. Okay, so please remember that, very important. Okay, it's very important. And then this whole thing, we prove that it's this one, this thing over here is this one over here. So far, so good. Alright, let's continue. So when you rearrange this thing, I'm not gonna do that for you. Alright, just straightforward. So it's just sum them up together. Alright, meaning I take this one, I multiply by its roots, z minus e minus at, and take this one, I multiply by z minus 1, this one is z minus 1. You get what I mean? So I'm trying to combine their denominator into one fraction over here like this. It's straightforward. It's just telling you that 5 over 3 plus 4 over 2. Alright, so you're going to multiply the whole thing by 2 over 2 and 3 over 3. So therefore you have 10 plus 12 over 6. You see, the fraction now is combined already. Just now is one piece like that. Now 3 times 2, 6. Everything combined. I think you get what I mean already lah. Alright, so hope that this is pretty clear to you right now. Alright, so far I'm talking about is only talking about the z transform of gs over s, which is the one that we've derived over just now. Alright, this thing over here. Alright, so I'll just simply copy this thing. I know this is a bit long and tedious already, but hopefully this is pretty much clear to you. Alright, so I'll just paste it over here. Okay, and then this thing over here that we will solve just now is this one. Okay, so if you don't believe me, it's 1 minus z minus 1, right? So it's equals to 1 minus 1 over z is equals to, if you were to rearrange, we know that 1 is z minus z because everything is equals to 1. So if you want to do that, you have z minus 1 over z, which is this one over here. Alright, so this thing I've proved to you is this dude over here. And then this thing that we have just previously found, stating that we do a z transform of gs over s, which is this one over also, you just bring it all over here. Alright, and in other words, this thing is also this thing. So this whole thing is this thing, and also this thing is the one that I've been keep doing for quite a long time already. Alright, that makes you a bit boring. And therefore you just combine already, so this z minus 1, this minus cancel, this thing and this thing cancel. What we'll have is 1 minus this thing over here. Alright, so I think this is pretty cool. I just highly suggest you click this link in your PDF so you can go to the slides over here. Alright, this is the z table. Is a pretty full-fledged table. Alright, yeah, and then I think this is it for this series, trying to do with the 0th order and how it's been applied from digital to analog and analog to digital. Alright, digital to analog, analog to digital. I shall see you soon in other stuffs.